So for in-class question 3, we have basically the same parameters as in-class question 2 with some small changes. Okay, so the first, so the wheelbase remains at 2.438 meters. Okay, and the velocity is still 60 miles per hour, which equals 26.8224 meters per second. Okay, the radius remains at 250 meters, and the weight M is also 1,784 kilograms, which hasn't changed. But this time, the weight distribution is 2 to 3 front to rear. So this time, the weight is more rear biased than in the previous question. The tyre characteristics are the same as before, and the questions are largely the same with the exception of F, which says find the critical speed. So let's work out A. We want to find the slip angles. Okay, so we've got the equations for alpha F and alpha R, okay, that we had previously. So we've got mv squared upon 2r, the 2 is there because we've got 2 tyres, d upon L, and then 1 over C alpha F. Okay. Now to find C alpha F, we need to find the mass or the load on the front axle, the vertical load, so that's FZF. That's going to be MF times by G per tyre divided by 2. So that's going to be M D upon L times by G upon 2. So we'll plug in the numbers, 1784. D upon L, well that ratio is going to be 2 divided by 5. Okay, and then we've got 9.81 divided by 2. So that comes out to be, the sums, 1784, 2, 5 divided by, times, okay, 9.81 times 2 divided by, so 3,500 newtons. So again, that number isn't actually explicitly on the table, but we do know that it's halfway between 3,000 and 4,000, and so the cornering stiffness will also be halfway between the cornering stiffness of 3,000 and the cornering stiffness of 4,000, which, by looking at it, the difference between the two is 240, so 120 is halfway, so add 120 to 760, we're going to get 880. So it's 880 newtons per degree. Okay, so alpha F, 1784, 26.8224 squared divided by 2r times by 2 over 5 times by 1 divided by 880. And if we do that sum, so we get 1784 times by 26.8224 squared, 824 squared, divided by 2, divided by 250, and then we've got, what else? We've got d upon 2, so times, divided by 5, and then we've got C alpha F, which is 880 divided, so we get 1.166, or 167, 1.167 degrees for alpha F. For alpha R, same equation, mv squared upon 2r d upon L, that's the difference, 1 over C alpha R. So again, we need to work out what FZR is, okay, which is going to be MR G upon 2, which is going to be M C upon L G upon 2, which is 1784. We've got 3 over 5 this time, 9.81 divided by 2. So this comes out, what does this come out to be? 1784. We've got 3, 5, and then 9.81, 2 divided by. So 5250 newtons. 5250 newtons. So again, that's between 5,000 and 6,000. This time I will interpolate, so let's draw the graph to make it clear what's going on. So this is the load, Fz, this is C alpha R, okay, and we've got this point, which is at 5,000, we've got this point, which is at 6,000, and this point here we know is 1140.2, and this point we know is 1330.3, and we've got 5250 here. That's the line. And this is C alpha R. So from inspection, we can say that that's going to be, let's see, 1140.2 plus, and we've got, what have we got? We've got 6,000 minus 5,000 over 1330.3 minus 1140.2 times by 5250 minus 5,000. Okay, so again, sums 1140.2, and we've got 1330.3, 1140.2 over 1,000 times by 525, oops, over 1,000, 5250, 5,000, subtract that, okay. So we've got swap, we divide by that, multiply by that, and add that. 1188 newtons per degree. Let's check that. 1330.3, 1140.2. So drop, and we subtract that. 4 divided by, and then we add that to 1140.2. Plus, yes, okay, that's correct. Okay, so that's our alpha, that's our C alpha R. And so we can then plug it into our equation for alpha R. So that's going to be 1784 times by 26.8224 squared divided by 2R times by 3 over 5 times by 1 over 1188 equals, so again, 1784 26.8224 squared, 250, then we've got 3, 5, and then we've got 1188. So 1.296 degrees. Okay. So they're the slip angles, front and rear. So part B says what's the lateral acceleration? Well, by B, AY is V squared upon R, 26.8224 squared divided by 250. This should be the same as in part A, 2.8778. 2.8778 meters per second squared. Okay, part C. Find the steering angle, so delta equals L upon R, or in fact 180 divided by pi L upon R plus alpha F minus alpha R. 180 divided by pi, 2.438 divided by 250 plus 1.167 minus 1.296. So this equals 180 pi 2.438, 250, and then we've got 1.167, 1.296. So we've got 0.42, well, 430, 0.430 degrees. Okay, oops. Okay, part D asks for the understeer gradient. So that's Ku is m divided by 2l. And then we've got d upon c alpha f minus c upon c alpha r. And since the rear slip angle is greater than the front slip angle, we're looking for a negative number here. So let's work it out. We've got 1784 divided by 2 times 2.438. And then we've got to find d. So we know that d upon l is 2 over 5. So that makes d equaling 2 over 5 times l. If we do the sums, that comes out to be 9.9752. 0.9752 divided by alpha, or c alpha r, c alpha f even, and that was going to be 880, that's right, so 880. Then we've got minus, and then we've got the value for c. Okay, c upon l is 3 over 5, so that means that c is 3 over 5l, and that, I believe, comes to 1.4628. Oops. 28. So that's 1.4628 divided by 1188. And if you do the sum for this, 1784 divided by 2 divided by 2.438, then we've got 0.9752 divided by 880, and we've got 1.4628 divided by 1188. Subtract those, multiply by that, we get minus 0.0451 degrees per meters per second squared. Part E asks for the Quarian characteristic, and this is straightforward. Because alpha f is smaller than alpha r, this indicates that the car is oversteering. Part F says, well, if the car is oversteering, what is the critical speed, v crit? And this is the velocity at which the steer angle required would be 0. And if you go through the notes, that was determined by an equation that looked a bit like this. So 57.3, which is 180 over pi, L divided by the understeer gradient. And if we were to go through that motions, so we've got minus 57.3, L is 2.438, divided by Ku, which is minus 0.0451. So if we do those sums, so I'll do 180 over pi divided by, and then we've got 2.438, and then we've got, that number's already there, so if we swap them round, divide, make it negative, square root, we get 55.68 or 7 meters per second. And if we were to put that in miles per hour, so that's meters per second, miles per hour, we've got 125 miles per hour.